In this video, we shall do problems 2.3, number 1 and number 2 from Elementary Number Theory by D.M. Burton. The first one says that if A divides B, we have to show that minus A divides B, A divides minus B, and minus A divides minus B. So let's do that. Solution number 1. Okay. So it's given to us that A divides B. So if A divides B, we can write B as A into some integer x. X is an integer. First we show that minus A divides B. So firstly we show that minus A divides B. Okay, so from there, here B equal to AX, we want to get minus A, right? So what shall we do? We modify here. We can write this one as minus A into minus X. Okay, and then we have B. See here, X is an integer, so minus X is also an integer. So let us write minus X as Y. Okay, where Y is equal to minus X is an integer. So from here it implies that minus A divides B. Okay, next, secondly, we show that A divides minus B. Okay, now here A divides B implies B is equal to A into X. X is an integer. Okay, then now we want to show that A divides minus B. So what we do, we multiply by minus sign on both sides. Okay, now from here, X is an integer, so minus X is also an integer. Let that be Y. Okay, equal to minus X, which is an integer. Now from here it implies that since minus B is equal to A into some integer, then it implies that A divides minus B. Okay, thirdly, we show that minus A divides minus B. Okay, now here we have A divides B, so it implies B is equal to A into some integer X. Okay, what do? We want to show that minus A divides minus B, so multiply by minus on both sides. We have like this. Now we see that minus B is equal minus A into some integer X. Okay, so from here it implies that minus A divides minus B. As simple as that. Okay, so we have done with number 1. Now let us do number 2. In number 2, A, B, C, D are integers. We have to verify these 4. The first one, A divides B, then A divides BC. Okay, let's do that. Okay, now we come to this one. What is that? A. Okay, 2A. See what is given to us. It's given that A divides B. And what do we have to show? We have to show that A divides BC. Since we have A divides B, it implies B is equal to A into some integer X. Okay, so what should we do if we want to get BC? We multiply by C on both sides. Okay, next, what do we have? From here, x is an integer, C is also an integer, right? So product of two integers is again an integer. Let us denote that one by y. Y equal to xc, which belongs to integer, to the set of integers. So since bc is equal to a into some integer, it implies that a divides bc. Okay, very simple. Let's do b. Okay, number b. If a divides b and a divides c, then a square divides bc. It's given that a divides b and a divides c. And what do you have to show? A square divides bc. Okay, now since a divides b, it implies that b is equal to a into some integer x. Okay, and we also have a divides c, so it implies that c is equal to a into some integer y. Okay, now we want to show that a square divides bc. So to get bc, what do? We have to multiply these two equations. So what do we have? B into c, we have a square xy. X is an integer, y is an integer, so product of two integers is again an integer. Let that one be z. Okay, since we have expressed bc as a square into some integer, okay, where your z is equal to xy, which belongs to the set of integers, we conclude that a square divides bc. Very simple. Okay, now let's do number c. Number c says that if a, okay, here we have to prove both ways. A divides b if and only if ac divides bc. C is not equal to 0. That means first we assume that a divides b. We shall prove that ac divides bc. Conversely, we assume that ac divides bc. We prove that a divides c. Okay, let's do that. So for number c, firstly, okay, now for what way? Let a divide b. Okay, what do we have to show? We have to show that ac divides bc. AC divides bc. Since a divides b, what do we have? B is equal to a into some integer x. X is an integer. Now what to do in order to get bc? We multiply on both sides by c. Okay, now see here, write this one as cx. It's the same only. Okay, so see, bc is written as ac into some integer x, so it implies that ac divides bc. Okay, that is one way. Now conversely, we prove the converse way. We assume that let ac divide bc, and then we show that a divides b. Okay, since ac divides bc, it implies that bc is equal to ac into some integer x. Okay, so from here clearly b is equal to a into x. Since b is expressed as a into x, then a divides b. Okay, and now we prove the last one. What is that? Okay, d. It's given to us that a divides b and c divides d. We have to prove that ac divides bd. If a divides b, we write b as a into some integer x, and if c divides d, then d is equal to c into some integer y. X and y are integers. Okay, now we want to show that ac divides bd. So what we do, we multiply these two, b into d, a into cxy. Now bd is equal to ac. See here, x is an integer, y is an integer, product of two integers is again an integer. Let that one be z. Okay, is equal to xy, which belongs to the set of integers. So from here it implies that AC divides BD. Hence, done.